Until very recently, artificial intelligence lived far away, locked inside massive remote supercomputers housed in glowing server farms. Maintaining that massive cloud infrastructure requires staggering capital. Around April 1st, SpaceX confidentially filed draft registration documents with the SEC. This visualization scales SpaceX's projected $1.75 trillion valuation against historical tech IPOs. They are preparing a capital raise of up to $80 billion to fund physical infrastructure projects like Starlink and their post-merger integration with xAI. Building at this macro scale exerts crushing physical and operational pressure on leaders of these companies. The race to dominate the cloud creates heavy internal friction. On April 3rd, OpenAI initiated a leadership reshuffle. Fiji Simo, the CEO of AGI Deployment, announced an extended medical leave to manage a worsening neuroimmune condition after postponing treatment to keep up with intense scaling demands. But that distant, cloud-first model is reaching its limit. The first week of April 2026 revealed a decisive pivot, moving processing power out of remote data centers and into our immediate environments. These trillion-dollar financial events and corporate shifts show that AI revolution is leaving the remote server and moving toward your daily routine and your workplace. On April 2nd, Google DeepMind released the open-source Gemma 4 family of models, explicitly designed to run locally on your personal hardware. They dropped several variants, including edge-optimized models built specifically for phones and laptops, alongside a denser 31 billion parameter version. These are engineered from the ground up to bypass cloud servers entirely. This schematic shows a mixture of experts architecture. Instead of activating the entire network for a single query, the system routes tasks only to specific subnetworks. This radically reduces the computational power needed to process information. Because of this efficiency, developers are already running full text and image reasoning entirely offline on devices like the iPhone 17 Pro, hitting speeds around 40 tokens per second without an internet connection. By releasing these models under a commercially permissive license, Google pushed advanced processing out of rented data centers and turned it into a privately owned utility sitting right in your pocket. This localized computing power is advancing rapidly from personal devices directly into the core of professional medical infrastructure. During a late March panel, Dr. Mitchell Katz, the CEO of NYC Health and Hospitals, stated plainly that his organization could replace a great deal of human radiologists with artificial intelligence right now. His proposal uses software to autonomously perform initial reads on low-risk imaging, like standard X-rays and mammograms, leaving human doctors to handle only the abnormal results to manage rising patient demand and lower costs. Radiologists are actively pushing back against this proposal, citing severe concerns over patient safety, diagnostic accuracy, and a lack of clear regulatory oversight. This friction in the medical sector mirrors broader efficiency moves across the economy. At the exact same time, Oracle reportedly laid off thousands of employees to reallocate capital toward artificial intelligence data center expansions. As this technology physically enters the workspace, it drops the facade of a helpful novelty and operates as a direct driver for white-collar labor displacement. On April 4th, Elon Musk made public statements detailing the final step in this proximity progression, moving processing hardware directly inside human biology. Musk reiterated his confidence that upcoming Neuralink human trials, targeted for 2026, will achieve the technological restoration of both hearing and vision. This diagram illustrates how the blindside implant functions. It completely bypasses the physical eyes and optic nerves, and instead directly stimulates the visual cortex at the back of the brain to generate sight. This biological integration relies on extremely fast hardware development. Musk simultaneously highlighted Tesla's new in-house chip research fab, where they handle all logic, memory, and packaging under one roof to accelerate iteration. By tightening the feedback loop on microchip design, they are rapidly closing the physical distance between silicon processing and human neural tissue. Events from the last week connect trillion-dollar space infrastructure to offline mobile software and eventually to human biological implants. The record-breaking capital raises and the severe executive burnout we are seeing are the structural shockwaves of an industry pushing towards total physical integration. The brief period where artificial intelligence functions strictly as a detached software service operating in a web browser is over. Stop looking up at the cloud for the future. It runs locally in your hands and targets your biology.